Hello and welcome to Classes with Atish. In today's lesson, we will continue with kinematics, and this is the third installment of kinematics lessons. After we conclude today's lesson, we will go over solving some problems in kinematics so we can test all the concepts that we have learned so far. Okay, so let's get started. Let me introduce you to one of Galileo's laws. Let's call this Galileo's odd number rule. And this applies for freely falling bodies. So when I say freely falling or free fall, what that means is the initial velocity u is 0, the acceleration that is working on the body is minus g because it's in the negative direction. These are the conditions that the body is acted upon. So let's say a body is dropped here, the ground is somewhere here. Okay. Now after time t1 or time t, the body covers s1 distance. At time t2, the body covers s2 distance. At time 3t, the body covers s3 distance and such. Okay. What Galileo's odd numbered rule says is the distances covered, the successive distances covered in equal intervals of time, they are at a ratio of, so s1 to s2 to s3 is at a ratio of 1 is to 3 is to 5. It goes like that. It's a very interesting rule, and if you remember this, a lot of problems can be solved very easily. Now let's see how this is happening. Okay, we know the conditions of free fall. Okay, now let's use the equations of motion under constant acceleration case and see how this works out. Okay, so if we have to find out the distance that the body traveled after t seconds, so s1 will be ut plus half at square. Now remember, u initial velocity is 0 and acceleration is minus g, so s1 is minus half g t square. Okay. Now what would s2 be? S2 is S1 plus S2 minus S1. Okay. Now S1 plus S2 is the total distance that is covered in 2t seconds. Right. So this will be u times 2t plus half a 2t square minus s1. Okay. Now u is 0, a is minus g, so minus half g times 4t square minus s1. Now this is minus 2gt square minus, what is s1? S1 is minus half gt square. So how much is this? So minus 2gt square plus half gt square. This is minus 3 by 2 gt square. Okay. So how much is S1 divided by S2, which is this ratio? Minus half gt square divided by minus 3 by 2 gt square. or this is 1 by 3. Okay, so we could already prove this. Now let's look at S3. Okay, now let's look at S3. S3 can be said to be S1 plus S2 plus S3 minus S1 plus S2. So this is, so S1 plus S2 plus S3 is nothing but the distance that is covered in 3t seconds. So if we use this formula, so we know initial velocity is 0, so this will be minus half g, t is 3t square, minus S1 plus S2 with the sign convention, it is, if we add these two, is minus 2 gt square. Now let's look at this. So this is minus 9 by 2 gt square plus 2 gt square, or we can say 4 by 2 gt square. So how much is this? Minus 9 plus 4 is minus 5 by 2 gt square. Now let's look at S1 to S3. So S1 is minus half gt square and S3 is minus 5 by 2 gt square. So what's the ratio? 1 by 5. So it shows, so the ratio of distance covered in the first t seconds to distance covered in the next t seconds to distance covered in the next t seconds, so equal intervals of time, are in a ratio of 1:3:5, which is the ratio of odd numbers. Okay, so very interesting rule to remember, but please do remember that this is only applicable for constant acceleration case and when the initial velocity is 0. It could be a free falling body, or even on a horizontal acceleration case with initial velocity 0, we can apply this principle. Okay. The next nice principle that you can remember is there is symmetry in motion under gravity. Okay. Let's say we launch a body with initial velocity u, upward direction. Okay, so the body goes up, at some point the velocity becomes 0 and then the body comes down. Okay, now let's say, so what's the equation of motion for this one? So at this point we know velocity is 0, right? So if we say v equals u plus at, remember the sign conventions. So final velocity is 0, initial velocity was positive u, minus acceleration is in the negative direction, gt. So t is equals to u by g. Okay, so the time taken to reach here is u by g. So this kind of motion actually exhibits a symmetry. It will take the same time t to go up and it takes same time t to come down, and when it comes down with the same velocity but in the opposite direction. Okay, now the symmetry is such, if let's say the distance covered in first second is s1, distance covered in second is s2, distance covered in third second is s3, like that. Let's say it takes 10 seconds to reach back, so distance covered in the 10th second will be this, distance covered in the 9th second is this, s8, and likewise let's say s4, this was s5, s6, s7. Okay, now the symmetry is such, s1 will be always equal to s10, s2 will be always equals to s9, and such. Okay, so the distances covered in the first second is equal to the distance covered in the last second. Similarly, distance covered in the second second is equal to the distance covered in the second last second. Okay, so remember this. Using this, actually many problems can be solved quickly. You don't need to do a whole lot of calculation using the equations of motion. Okay. The last concept that we will talk about today is the concept of relative velocity, relative acceleration, and even relative displacement. Okay. So let's say there is a ball A which is traveling with the velocity VA. Okay. And then there is another ball B which is traveling in the same direction with velocity VB. The initial position of A is XA, the initial position of B is XB. Okay, we can even say that acceleration of A is AA and acceleration of B is AB. Okay, now how do we find out what's the relative displacement of B with respect to A? We can denote x relative displacement of B with respect to A, this is a vector, as, so it will be displacement of B with respect to ground, which is xB vector, minus the displacement of A with respect to ground. Okay, so that is the relative displacement of B with respect to A. Okay. Similarly, if we have to find out relative velocity of B with respect to A, so think of it this way, that you are on this ball B and you are seeing how quickly you are going away from A. So what do we have to do? We have to position our frame of reference on A, and if we have to make sure that the frame of reference is not moving because it's with respect to that frame of reference, then we'll have to introduce a negative velocity on A. So this we can represent relative velocity of B with respect to A will be velocity of B with respect to ground. But now so these are the few concepts that I wanted to elaborate on, and this completes our basics on kinematics. Yes, there are a few other things that we can have some advanced classes on, but next what we'll do is we'll solve some problems to ensure all these concepts are clear. Okay, with that, let's close this lesson for today.